So when we graph this, we recognize this as a circle with a radius of 5. And they want the area between the circle and the line y equals 3. This is so lovely picture. It should be all nice and symmetric. We want this region going around the x-axis. Since we're going around the x-axis, let's prepare our functions. They should be y equals, like normal. It's good. And we're going to try to draw our radii. Now our radii go, you always start that radii at the axis of rotation and draw until you hit something. And whatever you hit is definitely the inner function. And here, in this case, we could go farther, right? So in this case, we will have an outer radius of that one. So you can see, like, when it spins around, the outside portion will spin out, carve a shape, but then this inside portion will carve out and kind of take away from that. So there's a hole in this figure. So when we find our volume, it's pi, and then the outer one is given by the height of the circle, so it's the square root of 25 minus x squared, so that's the outer radius squared. And then this inner radius is just 3 long, right? It's always 3 long no matter what. So that's 3 squared, and we have the dx. And we're taking that, since it's all with x's, what are the x's doing? They're going from, oh no, they're going from here to here. So we need to figure out those intersection points. We need to figure out where our function, 25 minus x squared, equals y equals 3. So if you square both sides, 25 minus x squared is 9. So minus x squared equals minus 34. So x is going to be plus or minus the square root of 34. Gross. So we're negative square root 34 down there, positive square root 34 up there. Alright, that's the setup. And now you just solve. So we're going to clean this guy up by calling it square root negative 34 to positive root 34. Square root and the square root cancel. 25 minus x squared minus a 9 dx. And I'm going to clean this up again. 25 minus 9 is 16 minus x squared dx. And I think, I normally don't like to do this. You could just keep these limits, but you do kind of realize that everything is nice and symmetric. It's a nice even function. So instead of having to plug in that silly square root 34 twice, I'm going to say that it's the same thing as from 0 to root 34, and I'm going to double it. That's going to save me some grief later. Don't have to take shortcuts, but I feel like it now. So
when you took the
yeah.
When you found the intersection points, you subtracted 25 from both sides, right?
Yeah.
And that gives you negative...
Whoops, it gives you negative 16.
Ha.
Ha! Thank you. Alright, so that's better. It's a 4. Ha! And so I don't have to deal with the root 34s. So I'm just going to deal with 4s. But I can still do my trick, but it would have been okay, even more okay. Thank you. That would have sucked. Cool. You're awake. It's awesome. Sweet. So, now just antiderivatives. So 16x minus x cubed over 3 from 0 to 4. And this is 2 pi. Plug in. I did 25 minus 9 right there. Alright, so it's plug in the 4, you get a 16 times 4 is 64 minus 4 thirds. Plug in the 0, you don't get anything. That is something. 64. What is that? I should be able to do this, but give a record. Let's see, we have 2 pi times negative 128 over. Oops, no, that's not right. So 64 times 3 minus 64 gives me 128 over 3, which should give me 256 pi over 3. And do they agree? 256 pi over 3. Heck yeah, we rule. That's it.
why did it go from -4 to 4 to 0 to 4?
0 to 4, because I still decided to take the shortcut instead of doing,
The whole thing?
yeah, I just took this part, spun it around, and doubled it. From 0 to 4, just this half.
Uh-huh.
And because it's nice and symmetric, as my picture shows, this part would be the same.
Right.
So, just
Okay.
0 to 4 doubled.
Okay.
Good?
How would it be different or more difficult to do it from -4 to 4?
Yeah, then you just wouldn't have the 2 there. And you
Huh.
have it from -4, and instead of getting a lovely 0 when you plug in the bottom, you
Oh.
would have gotten a -4, and you just would have had more numbers.
Okay, I see.
So,
Cool. Makes sense.